In the realm of philosophy, time has been a subject of profound inquiry, leading to the development of several major theories that seek to explain its nature and significance. One of the most prominent theories is the A-theory of time, often referred to as the presentism theory, which posits that only the present moment is real, while the past is no longer existent and the future is yet to come. Proponents of this view argue that our experiences are grounded in the now, emphasizing the immediacy of the present, as they believe that time is dynamic and ever-changing, with each moment bringing forth a new reality. In contrast, the B-theory of time, also known as eternalism, suggests that all points in time, past, present, and future, are equally real. This perspective treats time more like a landscape, where all events exist concurrently, regardless of our perception or experience. Advocates of this theory argue that time is just another dimension, similar to space, where all moments are laid out, allowing for a more timeless understanding of existence. Another significant philosophical approach to time is the idea of time as a linear sequence, often associated with the views of thinkers like Immanuel Kant, who proposed that our perception of time is shaped by our minds rather than by time itself. According to this view, time is not an objective feature of the universe, but rather a framework through which we organize our experiences, suggesting that our understanding of time is inherently subjective. On the other hand, there are cyclic theories of time, which can be found in various cultural and philosophical traditions, such as Hinduism and Buddhism, where time is viewed as a repeating cycle of birth, death, and rebirth. This perspective contrasts sharply with the linear views, emphasizing the repetitive nature of existence and suggesting that time is not a straight path, but rather a series of loops that reconnect at certain points. Moreover, there are also discussions around the nature of time in relation to change, where philosophers like Heraclitus famously stated that everything flows, indicating that change is fundamental to the understanding of time. This view emphasizes the idea that time cannot be separated from the changes that occur, and that our experiences of time are deeply intertwined with the changes in the world around us. Additionally, some contemporary philosophers have explored the implications of physics on our understanding of time, particularly through the lens of relativity theory, which suggests that time is not absolute, but can vary depending on the observer's state of motion. Presentism and eternalism are two philosophical theories about the nature of time, specifically regarding how we understand the past, present, and future. Presentism posits that only the present moment is real, meaning that the past is no longer existent, and the future has not yet come into being. This perspective emphasizes the immediacy of the present, suggesting that only what we currently experience matters. For presentists, statements about the past or future can be viewed as referring to things that once were or things that will be, but since they are not present, they lack real existence. For example, when we talk about historical events or future plans, we are merely referencing memories or predictions, rather than engaging with anything that possesses true reality. Yet, on the other hand, eternalism presents a different viewpoint, asserting that all points in time, including the past, present, and future, are equally real. This theory suggests that time is like a landscape where all events exist simultaneously, and just as we can observe different locations in space, the same applies to time. According to eternalists, past events are not gone, they continue to exist in a different temporal dimension, and future events, while not yet observable, are just as real as what we perceive right now. This perspective aligns with certain interpretations of physics, particularly in relation to space-time, where time is treated as a fourth dimension that encompasses all moments. The implications of these theories can lead to fascinating discussions about memory, perception, and the nature of reality itself. For instance, if presentism holds true, it raises questions about how we should value memories or historical knowledge, while eternalism invites us to consider a broader view of existence, one that transcends our immediate. The debate between these two theories touches on various philosophical, scientific, and even existential inquiries, challenging us to think about how we relate to time and our place within it. As we ponder these concepts, we can explore how they influence our understanding of change, identity, and the continuity of existence, ultimately shaping our perception of life itself. The block universe theory of time, often referred to as eternalism, presents a fascinating view of time and existence that challenges our everyday understanding. In this theory, time is seen as a fourth dimension, much like space, where all moments, past, present, and future, exist simultaneously, rather than flowing in a linear direction. Imagine a block of ice, where each point in the ice represents a specific moment in time, all frozen together, existing at once. Imagine a block of ice, where each point in the ice represents a specific moment in time, all frozen together, existing at once. This contrasts sharply with our common perception of time as a river, flowing from the past through the present and into the future, where we experience events one after another. In the block universe, every event that has ever happened, is happening, or will happen, exists in a vast, unchanging structure. This idea can be quite mind-bending, as it implies that the future is just as real as the past, and our experiences of change and movement are merely illusions or perspectives within this larger framework. Philosophers, physicists, and even some neuroscientists have delved into this concept, exploring its implications for free will, consciousness, and the nature of reality itself. One of the intriguing aspects of the block universe theory is its compatibility with certain interpretations of Einstein's theory of relativity. According to relativity, the concept of simultaneity is not absolute. Different observers can perceive events occurring at the same time differently, depending on their relative motion. This lends credence to the idea that all moments exist equally, rather than in a strict chronological order. Moreover, the block universe raises questions about how we understand change and causality. If all moments are equally real, then what does it mean for something to change? Instead of viewing time as a sequence of cause and effect, the block universe suggests that all events are interconnected within a single, timeless structure, leading to debates about whether our choices genuinely influence the future or if everything is already predetermined. The implications of this theory stretch beyond philosophy and physics, impacting areas like metaphysics, where discussions about the nature of existence and reality take center stage. Some proponents argue that accepting the block universe can offer a more coherent understanding of time, while critics might point out the difficulties in reconciling this view with our subjective experiences of time, passing and making choices. Additionally, the block universe theory has sparked interest in the realm of science fiction, inspiring narratives that explore time travel, alternate realities, and the nature of existence itself. These stories often reflect the tension between the time dilation is one of the most fascinating aspects of Einstein's theory of relativity, and it highlights how our understanding of time can change based on speed and gravity. According to Einstein's special theory of relativity, which he published in 1905, time is not a constant as we often perceive it, but rather it can stretch or contract depending on the relative speeds of observers. This means that if one person is traveling very fast, close to the speed of light, and another person remains stationary, the traveling person will experience time more slowly than the person who is stationary. This effect has been confirmed through numerous experiments, such as the famous Hafele-Keating experiment, where atomic clocks were flown around the world on planes. When the clocks were compared with those that remained on the ground, the results showed that the airborne clocks ticked slightly slower due to their high speed, demonstrating time dilation in action. Now, when we move to Einstein's general theory of relativity, published in 1915, the concept of time dilation takes on another layer as it incorporates the effects of gravity. According to general relativity, massive objects, like planets and stars, warp the fabric of space-time around them. This warping affects the passage of time. In regions of stronger gravitational fields, time runs slower compared to regions with weaker gravitational fields. For instance, a clock placed on a mountain will tick slightly faster than a clock at sea level, because the mountain is farther from the mass of the Earth, and thus experiences a weaker gravitational pull. This phenomenon has practical implications, especially for satellites in orbit around the Earth, which have to account for both types of time dilation, the speed at which they travel, and the gravitational effects of Earth, to maintain accurate GPS measurements. In summary, time dilation is a key feature of both special and general relativity, illustrating that time is not as straightforward as we might think. It bends and stretches in response to the relative motion of objects and the influence of gravity, leading to some truly mind-bending implications for our understanding of the universe. The concept of time as a fourth dimension is a fascinating idea that has intrigued scientists, philosophers, and thinkers for centuries. In our everyday experience, we perceive the world in 3 dimensions: length, width, and height. These 3 dimensions allow us to define the space around us, but when we introduce time into the equation, we enter a whole new realm of understanding. Time, often referred to as the 4th dimension, adds a temporal aspect to the spatial dimensions, allowing us to understand events not just in terms of their physical location, but also in terms of when they occur. This idea gained significant traction in the early 20th century, particularly with Albert Einstein's theory of relativity, which proposed that space and time are interconnected, forming what is known as space-time. In this framework, an event is described by 4 coordinates, 3 spatial dimensions and 1 temporal dimension. This means that to fully describe an event, we need to know where it occurs and when it happens, which fundamentally changes how we perceive reality. Einstein's theories suggested that time is not an absolute entity, but rather it can be affected by speed and gravity. For instance, time moves slower for objects moving at high speeds compared to those at rest, a phenomenon known as time dilation. This idea has been confirmed through various experiments, such as those involving atomic clocks on fast-moving aeroplanes, which show that the clocks on the planes tick slightly slower than those on the ground. The implications of considering time as a dimension are profound, leading to the understanding that our universe is a 4-dimensional continuum, where time is intertwined with the fabric of space. Moreover, the concept of time as the 4th dimension also leads us to explore philosophical questions about the nature of reality and how we experience it. For example, if time is a dimension similar to space, can we view our existence as a series of moments laid out in a 4-dimensional block, sometimes referred to as the block universe? In this model, all moments in time exist simultaneously, rather than flowing like a river from the past to the future. This challenges our intuitive understanding of free will and the linear progression of time. In addition, considering time as a dimension also has significant implications in various fields, such as physics, cosmology, and even computer science. In physics, it helps in understanding the behavior of particles at high speeds and the dynamics of the universe itself. In cosmology, it plays a crucial role in understanding the evolution of the universe. Philosophers have long pondered the nature of now, and this concept is far more complex than it might seem at first glance. For many, now is not just a simple point in time, but a rich and intricate phenomenon that raises questions about consciousness, perception, and existence. One of the key views comes from the realm of metaphysics, where philosophers like Immanuel Kant argue that our experience of time is deeply tied to our perception. Kant suggested that we cannot think of time independently of our experiences, meaning that now is always experienced through the lens of our consciousness, shaping how we perceive. In contrast, other philosophers, like Martin Heidegger, focused on the existential aspect of now. Heidegger believed that now is essential for understanding our being, as it is the moment where our past experiences converge with our future possibilities. He emphasized the importance of being present, arguing that many people get lost in thoughts about the past or future, thus forgetting the significance of the current moment. He argued forbidden fruits, thus forgetting the significance of the current moment. This perspective encourages a mindful approach to existence, urging us to appreciate the fleeting nature of now. Meanwhile, the debate continues with the presentism versus eternalism discussion. Presentism, held by thinkers like J.M. McTaggart, claims that only the present moment exists, while past and future events are unreal. This view posits that the now is the only time that is truly real, leading to implications for how we understand change and time itself. On the other hand, eternalism, supported by philosophers such as David Lewis, argues that past, present, and future events are equally real. In this view, now is just one perspective in a wider temporal landscape that exists all at once, suggesting that our experience of now is merely a subjective slice of a larger reality. Moreover, the way scientists approach the concept of now has also influenced philosophical discussions in the realm of physics, particularly with the theory of relativity. Time is not a constant, and what we perceive as now can vary depending on the observer's relative motion. Philosophers like Henri Bergson have engaged with these scientific insights, arguing that time is not just a series of moments, but a flowing continuum that is experienced differently by individuals. He emphasized the qualitative aspects of time, suggesting that the richness of our experiences cannot be captured by mere measurements, highlighting the profound depth of the now. Further complicating this topic, causality plays a fundamental role in theories of time, and understanding this relationship can illuminate how we perceive the flow of time itself. In many philosophical discussions, causality is viewed as a key component in defining time, as it provides a framework for understanding how events relate to one another. For instance, if we consider a simple cause and effect scenario, such as a ball rolling down a hill, the cause, the initial push of the ball, leads to a specific effect, which is the ball's motion. This sequence not only highlights the relationship between the two events, but also implies a directional flow of time. That is, the cause occurs before the effect, suggesting a past and a future. In physics, particularly in the context of relativity, causality is crucial because it helps define the structure of space-time. According to Einstein's theory of relativity, the speed of light is the ultimate speed limit in the universe, meaning that information cannot travel faster than light. This limitation ensures that causality is preserved. No effect can occur before its cause, regardless of the observer's frame of reference. This leads to the concept of light cones, where the events within the future light cone can be influenced by the events in the past light cone, reinforcing the idea that causality dictates the order of events in time. Philosophically, different theories have proposed various interpretations of time and causality. Presentism, for example, posits that only the present moment is real, and the past and future are not. In this view, causality becomes a bit more complicated, as it suggests that while we can observe the effects of past events, those events themselves do not exist in any tangible form. On the other hand, eternalism, which is sometimes summarized by the phrase, "all points in time are equally real," allows for a more robust interpretation of causality, as it posits that past, present, and future events coexist in a four-dimensional space-time fabric. Here, causality still plays a role, but it is viewed through the lens of a more complex structure of time. Moreover, in quantum mechanics, the role of causality becomes even more nuanced. The famous double-slit experiment, for instance, raises questions about how causality operates at the quantum level, where particles can exhibit behaviors that seem to defy traditional causal relationships. Some interpretations of quantum mechanics suggest that causality may not always follow the linear, predictable patterns we observe in macroscopic events. This, the arrow of time, is a fascinating concept in physics and philosophy, often linked to the second law of thermodynamics, which states that in a closed system, entropy, or disorder, tends to increase over time. This relationship provides a direction to time, as we observe that natural processes like the melting of ice or the mixing of cream into coffee move from states of lower entropy to states of higher entropy, creating a clear distinction between the past and the future. Imagine a broken glass on the floor. It's much easier to envision how it shattered into many pieces than to picture those pieces spontaneously reassembling into an intact glass. This one-way progression from order to disorder is what gives time its arrow, a direction that we can perceive in our everyday lives. In thermodynamics, entropy is often described as a measure of the number of ways a system can be arranged. And as systems evolve, they explore more possible configurations, leading to higher entropy. For instance, if you have a box divided into two sections, with gas molecules concentrated in just one side, over time those molecules will spread out to fill the entire box, increasing the system's entropy. As this happens, we can observe the arrow of time moving forward, as the initial state of low entropy transitions to a more disordered state. Moreover, this concept can also be tied to the universe's evolution. In the early moments after the Big Bang, the universe was in a state of very low entropy, highly ordered and uniform. As the universe expanded and evolved, it moved towards higher entropy, leading to the complex structures we see today, such as galaxies, stars, and planets, which themselves are constantly undergoing changes that increase entropy. This continual increase in entropy can be seen as a driving force behind the processes of nature, influencing everything from the life cycles of stars to the biological evolution of species. Interestingly, while the arrow of time is often associated with the increase of entropy, it also raises questions about the nature of time itself. Some physicists theorize that time might not be a fundamental aspect of the universe, whether so or not, but rather an emergent property, arising from the statistical behavior of particles and their interactions. This leads to intriguing discussions about whether time could behave differently under certain conditions, such as near black holes or in extreme gravitational fields, where the rules of thermodynamics might not apply in the same way we observe in everyday life. In summary, the arrow of time and entropy are deeply intertwined. Time travel, a fascinating concept that has intrigued both scientists and science fiction fans alike, raises numerous questions and implications in the realm of physics. At its core, time travel challenges our understanding of time as a linear progression, suggesting that it might be possible to move backward or forward through time, much like we navigate through space. One of the most significant implications comes from Einstein's theory of relativity, which posits that time is not a fixed entity, but rather a dimension that can be affected by speed and gravity. This means, theoretically, if someone were to travel at speeds close to the speed of light, time would slow down for them relative to someone who remains stationary, a phenomenon known as time dilation. This has been confirmed through various experiments, such as those involving atomic clocks on fast-moving jets or satellites, which show that time indeed behaves differently based on velocity. Moreover, the concept of wormholes, which are hypothetical passages through space-time, suggests another avenue for time travel. If these wormholes exist, they could connect distant points in both space and time, allowing for instantaneous travel. However, the existence of wormholes is still purely theoretical and comes with its own set of challenges, including the need for exotic matter to stabilize them. Additionally, the implications of traveling back in time introduce paradoxes such as the famous grandfather paradox, where a time traveler could potentially prevent their own existence by altering past events. These paradoxes create complex discussions about causality, challenging our understanding of cause and effect and leading to various interpretations of time, including the idea of multiple timelines or parallel universes, where every action creates a branching reality. Furthermore, the philosophical implications of time travel cannot be overlooked. If time travel were possible, it would raise questions about free will and determinism, as well as the nature of reality itself. Would our choices be predetermined if we could alter the past? Or would every change create a new timeline, leaving the original one intact? This leads to discussions about the ethical responsibilities of a time traveler. If one could travel back in time, what actions would be acceptable and what consequences could arise from even the smallest changes? In addition, the search for a unified theory of quantum gravity, which seeks to merge general relativity with quantum mechanics, may provide insights into the feasibility of time travel, as both frameworks currently exist in tension with one another. Quantum mechanics introduces concepts like superposition and entanglement, which might offer new perspectives on the fabric of the grandfather paradox. The grandfather paradox is a fascinating concept in the realm of time travel and theoretical physics, and it raises intriguing questions about causality and the nature of time itself. Imagine, if you will, a time traveler who goes back in time to a point before their grandfather had children. If this time traveler were to accidentally cause harm to their grandfather, or even prevent him from meeting their grandmother, it leads to a perplexing situation. The time traveler would never have been born. It creates a logical inconsistency. Because if the time traveler was never born, then how could they have traveled back in time in the first place? This paradox highlights the complexities of time travel, suggesting that the very act of traveling back in time could alter events in such a way that it negates the original purpose of the journey. In a nutshell, philosophers and physicists have debated various resolutions to this paradox, with some proposing the idea of parallel universes, where changes made in the past create a new timeline separate from the original one. Others suggest that time travel might be impossible, or that there are unbreakable laws of time that prevent such paradoxes from occurring. Yet, the grandfather paradox serves as a thought experiment that challenges our understanding of time, causality, and the potential implications of time travel, inviting us to ponder the nature of reality and the limits of our current scientific knowledge. Cultures around the world have distinct ways of perceiving time, which can greatly influence their lifestyles, traditions, and interactions. In many Western cultures, time is often viewed as a linear concept, where past, present, and future are distinctly separated, and punctuality is highly valued. This perspective can lead to a sense of urgency, where schedules and deadlines dominate daily life. And being late is often seen as a sign of disrespect or poor planning. In contrast, some indigenous cultures, such as certain Native American tribes, see time as cyclical, emphasizing the importance of seasons, natural rhythms, and the interconnectedness of past, present, and future. This approach fosters a deep appreciation for nature and its cycles, influencing their traditions, storytelling, and social gatherings. In many Asian cultures, time can be perceived more fluidly, with an emphasis on relationships over strict adherence to schedules. For instance, in countries like China, the concept of Chinese time suggests a more relaxed approach to punctuality, where flexibility is appreciated and social harmony may take precedence over rigid timelines. This perspective extends to business practices as well, where building relationships and trust can be more valuable than completing tasks on a strict timeline. On the other hand, cultures in countries like Germany or Switzerland exhibit a strong adherence to punctuality, viewing it as a sign of reliability and respect. The German word Pünktlichkeit embodies this cultural value, highlighting how time management is integral to societal norms. In the Middle East, time can also be perceived differently, often influenced by the significance of social gatherings and communal life. In many Arab cultures, the value placed on hospitality and personal relationships can lead to a more relaxed attitude toward time, where meetings may start later than planned, and conversations can take precedence over sticking to a schedule. This fluidity often reflects a broader cultural focus on community and connection rather than strict adherence to the clock. Moreover, some African cultures also perceive time in a more relational context, whereby events are often scheduled based on personal interactions and community needs, rather than strictly defined timelines. In many cases, the phrase African time refers to a more laid-back approach to scheduling, where the emphasis is on gathering together rather than adhering to a rigid schedule. Understanding these different perceptions of time can enrich our appreciation of cultural diversity and the varying ways people prioritize their lives, relationships, and responsibilities. It reminds us that while we may operate within our own time frameworks, there are countless ways of experience. The concept of time can be quite fascinating, and understanding the difference between linear and cyclical time can really change how we perceive our lives and the world around us. Linear time, as the name suggests, moves in a straight line from the past through the present and into the future. This idea is prevalent in many Western cultures, where time is often viewed as a series of events that happen one after another, much like a timeline. You might think of your life as a story, where each moment leads to the next, and where progress and development are emphasized. In this view of time, events are seen as unique, and once they pass, they cannot be repeated, which can lead to a sense of urgency and the importance of making the most of each moment. On the other hand, cyclical time is a concept found in many Eastern philosophies and indigenous cultures, where time is perceived as a repeating cycle, much like the seasons of the year or the phases of the moon. In this perspective, events are not seen as isolated moments, but rather as part of a larger, ongoing process. Life is viewed as a series of cycles, where birth, growth, death, and rebirth all play significant roles. This can foster a sense of continuity and connection to the past, as well as an understanding that everything is interconnected in a larger whole. For instance, in many agricultural societies, the cyclical nature of planting and harvesting is crucial, as it reflects the rhythms of nature and the importance of timing in relation to the environment. Moreover, the perception of time can influence how individuals approach their goals and relationships. In a linear time framework, people might prioritize future achievements, often leading to a focus on productivity and accomplishment. In contrast, those who embrace cyclical time might place greater value on community, tradition, and the present moment, recognizing that experiences repeat and that wisdom can come from reflecting on the past. This difference can significantly affect cultural practices, celebrations, and even how history is recorded and understood. In essence, while linear time emphasizes progress and the idea of moving forward, cyclical time highlights the importance of patterns, rhythms, and the idea that life is a series of repetitions and renewals. Each perspective offers unique insights into how we can live our lives, make decisions, and understand our place in the world, enriching our experience and knowledge of time itself. Quantum mechanics, a fundamental theory in physics, reveals fascinating aspects of reality that challenge our classical understanding of time, which we typically perceive as linear and absolute. In classical physics, time is viewed as a constant, flowing uniformly, where events occur in a predictable sequence. However, quantum mechanics introduces a more complex picture. At the quantum level, particles exist in a superposition of states, meaning they can be in multiple states simultaneously until measured. This notion of superposition calls into question the linear progression of time, as particles can appear to be in various places and times at once, leading to the idea that time may not be as straightforward as we think. Moreover, consider the concept of entanglement, which occurs when particles become linked in such a way that the state of one particle instantly influences the state of another, regardless of the distance separating them. This phenomenon suggests that information can be exchanged faster than the speed of light, challenging the classical notion of causality, which relies on a sequential flow of time where causes precede effects. In quantum mechanics, the relationship between time and space becomes less clear, as events can be interdependent in ways that defy traditional temporal ordering. Additionally, when we delve into the realm of quantum gravity, theories such as loop quantum gravity propose that time itself may emerge from more fundamental aspects of the universe, rather than being a primary entity. This idea posits that, at a microscopic scale, space and time could be quantized, meaning they consist of discrete units rather than being continuous. As a result, the very fabric of reality might be woven together in a way that fundamentally alters our perception of time, suggesting that it could be a construct arising from deeper underlying structures. Another compelling aspect is the role of the observer in quantum mechanics, which brings us to the famous double-slit experiment. In this experiment, particles such as electrons exhibit wave-like behavior when not observed, creating an interference pattern that implies they exist in a state of possibility. However, when an observer measures the particles, they collapse into a definite state, suggesting that observation itself influences reality. This raises intriguing questions about the nature of time, as the act of observation appears to create a moment of now that influences how we understand past and future states. Furthermore, researchers are exploring the implications of time in quantum mechanics through various interpretations. The many-worlds interpretation, for instance, posits that every quantum event branches off into different realities, creating a multiverse. The A theory versus B theory debate is a fascinating topic in the philosophy of time, and it dives deep into how we understand time, its passage, and our experience of it. At its core, the A theory, often called the presentist view, suggests that only the present moment is real, meaning that the past has already happened and the future has yet to occur, leaving us with a dynamic view of time. This perspective emphasizes the flow of time, where events are constantly moving from the future to the present and into the past, highlighting the importance of the present as the only moment we can truly experience. On the other hand, the B theory, also known as the tenseless view, posits that all points in time, past, present, and future, are equally real, suggesting that time is more like a landscape where all events exist simultaneously, rather than a flowing river. This view leads to a more static conception of time, where the distinctions between past, present, and future are more about human perception rather than objective reality. The significance of this debate lies not just in abstract philosophy, but also in how it affects our understanding of existence, causality, and even our own experiences. In knowing, for example, proponents of A theory argue that our emotional experiences, our sense of urgency, and our decision-making are all tied to the present moment, which shapes our reality. Conversely, B theorists may argue that this perspective can lead to a more coherent understanding of time's structure, where time itself does not flow, allowing for a more consistent interpretation of events and their relationships. This philosophical clash has implications for various fields, including physics, where the nature of time plays a crucial role in theories of relativity and the understanding of the universe. The debate also touches on issues of free will and determinism, as A theory might support a more flexible view of choice in a dynamic timeline, while B theory could suggest a predetermined structure where all events are fixed in their temporal positions. Philosophers and scientists alike continue to explore these ideas as they shape our fundamental understanding of reality and how we relate to the universe around us, with implications that reach far beyond mere academic discourse, affecting our perceptions, our beliefs, and even our daily lives. Subjective experiences of time can be incredibly fascinating, as they highlight the ways in which our minds perceive the passage of time, which can often be quite different from how time is measured objectively, using clocks and calendars. When we talk about objective measurements, we refer to the precise, standardized way time is quantified. For example, a second is always 60 beats of a metronome, or a minute consists of 60 seconds, regardless of individual perception. And this is just a piano eye to me. In contrast, subjective experiences of time can feel fluid, influenced by various factors, such as emotions, attention, and the specific activities we engage in. For instance, when we are having fun, time seems to fly by, and an hour can feel like mere minutes, while during moments of boredom or anxiety, those same 60 minutes can stretch on endlessly, creating a sense of time dragging. This phenomenon can be attributed to the way our brains process information. When we are highly engaged in an activity, our brains take in more information, creating richer memories, which can make time feel shorter in hindsight. On the other hand, during dull or repetitive tasks, our brains may not register as much detail, leading us to feel as if time is passing more slowly. This difference is not just anecdotal. Psychological studies have shown that our perception of time can be altered by age, cultural factors, and even physical states, such as whether we are tired or excited. Interestingly, research has indicated that people tend to estimate time intervals differently based on their emotional state. Happy moments can create a sense of time flying, while sad or stressful times can lead to a feeling of time dragging. Additionally, the concept of time dilation in physics has parallels in our subjective experiences, where time appears to slow down under extreme conditions, such as during life-threatening situations. In these moments, our brains may heighten awareness, making us feel as if time is stretching. Furthermore, our daily routines and habits can also shape our perceptions. For instance, when we are on vacation, new experiences can make time feel more abundant, whereas the repetitive nature of daily work can make time feel scarce. Cultural differences also play a vital role, as some cultures view time as a linear progression, while others may see it as more cyclical, impacting how individuals experience and talk about time. In this complex interplay between subjective experiences and objective measurements, we find that while clocks may tick at a constant rate, our internal clocks are anything but uniform, showcasing the intricate relationship between our minds and our minds. The relationship between time and consciousness is a fascinating topic that has intrigued philosophers, scientists, and thinkers for centuries. At its core, consciousness refers to our awareness of ourselves and our surroundings, while time is the ongoing sequence of events that we experience. One way to understand this relationship is by exploring how we perceive time. Humans have a unique ability to reflect on past experiences, anticipate future events, and navigate the present moment, which showcases the complexity of our conscious experience. Research in psychology suggests that our perception of time can be influenced by various factors, such as attention, emotions, and the nature of the tasks we engage in. For instance, when we are deeply focused on an activity, time seems to fly by, whereas moments of boredom can stretch time out, making it feel longer. This phenomenon highlights how consciousness shapes our experience of time, as our thoughts and feelings can alter how we perceive its passage. Additionally, philosophical discussions around time often touch on the concept of now, which is the present moment where consciousness occurs. Some philosophers argue that the present moment is the only true point of reality, suggesting that both the past and future exist only in our minds, as memories and anticipations respectively. This raises important questions about the nature of existence and how consciousness interacts with the flow of time. In the realm of neuroscience, studies have shown that different parts of the brain are involved in processing time information. For example, the suprachiasmatic nucleus, a tiny region in the brain, plays a crucial role in regulating circadian rhythms, which are the natural cycles of our body related to sleep and wakefulness. This biological clock influences our consciousness as it affects our alertness, mood, and overall awareness throughout the day. Moreover, some theories propose that consciousness itself may have a temporal dimension, meaning that our conscious experiences could be linked to a kind of mental time travel. This idea suggests that we can mentally navigate through time, reliving past memories or projecting ourselves into the future. This ability to internally simulate different points in time could be fundamental to our understanding of ourselves and our decision-making processes. Lastly, the nature of time itself is still a subject of scientific inquiry, with theories in physics, such as relativity, challenging our traditional notions of time as a constant and linear progression. These scientific perspectives can also influence our understanding of consciousness, as they prompt us to reconsider how we think about existence and awareness. The interplay between consciousness and time is not the concept of time plays a crucial role in shaping ethical decision-making, as it influences how individuals perceive situations, evaluate consequences, and prioritize values. When people think about time, they often consider not just the present moment, but also the past and the future. For instance, in the context of ethical dilemmas, a person's past experiences can inform their values and beliefs, guiding their decisions in the present. If someone has previously faced a similar situation, their memories of that experience might lead them to make a choice based on what they learned, or even how they felt about the outcome. Moreover, the urgency of time can significantly impact decision-making processes. When faced with time constraints, individuals may resort to snap judgments or rely on heuristics, which are mental shortcuts that simplify decision-making. This can lead to different ethical outcomes, especially if a quick decision overlooks important details or fails to consider the broader implications of an action. For example, in business environments where deadlines are tight, leaders might prioritize short-term gains over long-term ethical considerations, potentially harming stakeholders in the process. Additionally, the temporal perspective can affect how individuals weigh the consequences of their actions. Those who are mindful of future repercussions might be more inclined to consider long-term effects on their community or the environment, whereas a more immediate focus could lead to decisions that benefit oneself in the short run but cause harm later. This phenomenon is often seen in discussions about climate change, where immediate economic interests may clash with the ethical responsibility to protect the planet for future generations. The way time is perceived, whether as a linear progression or as a series of interconnected moments, can shape these considerations and ultimately guide ethical choices. Cultural factors also play a role in how time influences ethical decision-making. In some cultures, a more collectivist approach may encourage individuals to consider the impact of their decisions on the group, leading to a longer-term view of ethical implications. In contrast, more individualistic cultures might emphasize personal autonomy and immediate outcomes, which can shift the ethical landscape. The values surrounding time, whether they lean towards punctuality and efficiency or patience and reflection, will affect how ethical dilemmas are approached and resolved. Finally, the psychological aspect of time cannot be overlooked. Research shows that individuals with a future-oriented mindset tend to engage in more thoughtful and ethical decision-making, as they are more likely to reflect on how their choices will affect others down the line. Conversely, those who focus primarily on the present may struggle with considering the ethical dimensions, In the theory of relativity, time plays a crucial role, fundamentally altering our understanding of how the universe operates. Albert Einstein, in his groundbreaking work, proposed that time is not a constant, as previously thought, but rather a dimension that is intertwined with space, forming what we call space-time. This means that the passage of time can vary depending on factors such as speed and gravitational influence. For instance, according to the special theory of relativity, as an object moves closer to the speed of light, time for that object slows down relative to an observer at rest. This phenomenon is known as time dilation, and it has been confirmed through various experiments, including those involving precise atomic clocks placed on fast-moving aircraft or satellites, which show that time indeed passes more slowly for them compared to clocks on the ground. Furthermore, the general theory of relativity expands on this by introducing gravity into the equation, showing that massive objects like planets and stars can warp the fabric of space-time, creating a gravitational field that affects the flow of time. Near a massive body, such as a black hole, time appears to slow down significantly compared to regions of weaker gravity, leading to the intriguing concept that time is experienced differently depending on one's position in a gravitational field. This means that if two people were to experience time in different gravitational environments, their personal clocks would not synchronize, resulting in different aging processes, which is often illustrated in science fiction scenarios where astronauts travel near black holes and return to find that many more years have passed on Earth. Moreover, time's relativity challenges our intuitive notions of past, present, and future, as events that are simultaneous for one observer may not be for another, depending on their relative motion. This leads to the idea that the universe does not have an absolute time frame, but rather a more complex structure where time intertwines with space. The implications of these theories are profound, influencing not only physics, but also philosophy, as they prompt us to rethink our concepts of reality, causality, and existence itself. In essence, time in relativity is not merely a ticking clock, but a dynamic aspect of the universe, deeply connected to the very fabric of space-time, revealing a reality that is richer and more complex than we might ever have imagined. The theory of time as a mental construct presents a fascinating challenge to physical realism, which posits that the physical world exists independently of our perceptions. When we think of time, we often envision it as a linear progression, a steady stream that carries us from the past, through the present, and into the future. However, the idea that time might not be an objective feature of the universe, but rather a product of our minds, invites us to reconsider our understanding of reality. Philosophers and scientists alike have explored this concept, suggesting that time may be more about human perception and less about an external clock ticking away. This perspective is grounded in the notion that our experience of time is deeply subjective, influenced by our emotions, memories, and the context of our lives. For instance, when we are engaged in enjoyable activities, time seems to fly by, while moments of boredom can stretch on endlessly. This subjective experience raises questions about the nature of time itself. If our understanding of time is shaped by our mental processes, can we truly say that time exists in a concrete sense, independent of our thoughts and feelings? Moreover, this theory aligns with certain interpretations of quantum mechanics, where the act of observation plays a crucial role in determining the state of a system. In this framework, time, like many aspects of reality, may be more about relationships and interactions, rather than an absolute flow. For example, some physicists argue that at the quantum level, events do not have a definite order until they are observed, suggesting that time could be more of a construct created by our minds to make sense of the universe around us. This raises intriguing implications for our understanding of reality. If time is indeed a mental construct, it challenges the idea that physical realism, which relies on the existence of an objective external world, can fully capture the complexity of our experiences. Instead, it suggests that our perceptions and consciousness play an essential role in shaping how we understand and interact with the world. Consequently, this perspective opens up a dialogue about the nature of existence itself, prompting us to consider whether reality is a tapestry woven from both physical elements and the intricate threads of human thought and experience. In essence, viewing time as a mental construct forces us to confront the limitations of our traditional understanding of the universe, inviting a more nuanced exploration of the interplay between mind and matter, between the subjective and the objective, and ultimately between what we perceive and what is. This challenge to physical realism not only enriched the philosophical problem of temporal parts, often discussed in metaphysics, revolves around the concept of objects existing at multiple times, and whether they can be considered as having different parts at different times. This idea, also known as perdurantism, suggests that instead of viewing objects as wholly present at a single moment, we can think of them as having temporal parts, or stages, that correspond to different times in their existence. For instance, consider a tree that grows over many years. Instead of seeing the tree as one unchanging entity, we can think of it as consisting of a series of temporal parts, each part representing the tree at a specific moment in time. This leads to intriguing questions about identity and persistence. If a tree at one moment is a different part than the tree at another moment, what does it mean for the tree to be the same tree over time? This brings us to the concept of the problem of temporary intrinsics, which asks how objects can have different properties at different times while still being considered the same object. For example, a tree may be green in the spring and bare in the winter. How can it be said to have the same identity despite these changes? Philosophers debate whether we should think of objects as three-dimensional entities that persist through time, or as four-dimensional entities that extend through both space and time, composed of these temporal parts. The implications of this debate extend beyond trees to all kinds of objects and beings, including ourselves. If we think of ourselves as having temporal parts, we might wonder how our past selves relate to our present selves, or how our future selves are connected to who we are now. This raises questions about personal identity, responsibility, and the nature of change. Furthermore, this issue intersects with discussions about time itself. If time is understood as a dimension similar to space, then it becomes essential to consider how we conceptualize our experiences as temporal beings. Exploring these ideas can lead us into deeper waters, such as the nature of time, the flow of time, and how our perceptions of time influence our understanding of existence. The philosophical problem of temporal parts continues to be a fertile ground for inquiry, provoking rich dialogues among philosophers and inviting us to reconsider our intuitions about what it means to exist, to change, and to be the same over time. Each perspective, whether one leans toward perdurantism or holds a more traditional view of identity, offers unique insights that can reshape our thinking about life. Time zones, which divide the world into different regions, each with its own standard time, significantly influence how we perceive and coordinate time across various parts of the globe. And the Earth rotates on its axis, completing a full rotation approximately every 24 hours, which means that, as different regions experience daylight, others are in darkness, creating a complex tapestry of time. When the concept of time zones was first proposed by Sir Sandford Fleming in the late 19th century, it was primarily to address the confusion caused by the numerous local times that existed before, leading to difficulties in scheduling trains and other forms of transport. This system, which divides the world into 24 time zones, each roughly 15 degrees of longitude apart, allows for a standardized way of telling time, making it easier for people to communicate and conduct business across distances. However, this division can sometimes lead to misunderstandings and complications, especially in our increasingly connected world. For example, when planning a meeting with participants located in different time zones, one must carefully calculate the time difference, which can range from a few hours to a full day, depending on where you are in the world. This complexity can sometimes result in people showing up at the wrong time, creating confusion and frustration. Additionally, the introduction of daylight saving time in many regions, where clocks are set forward by 1 hour during warmer months to extend evening daylight, can further complicate these calculations, leading to even more discrepancies in timekeeping. Sure, moreover, time zones can impact our daily routines and cultural practices in various ways. For instance, businesses operating internationally often have to adapt their working hours to accommodate clients and partners in other time zones, sometimes leading to employees working odd hours to stay in sync. This adaptation can affect everything from sleep patterns to social interactions, as people find themselves awake during hours they would typically reserve for rest. On a broader scale, time zones can also influence social and cultural events, such as New Year celebrations, which occur at different times around the world, creating a unique global experience that reflects the diversity of human culture. In addition, our understanding of time is also shaped by the technology we use. In the digital age, with the advent of the internet and smartphones, we have access to real-time information and communication, making it essential to be aware of time differences. Applications and software often automatically adjust for these differences, helping users schedule events and meetings without the hassle of manual calculations. However, this constant connectivity can blur the lines between work and personal memory. Memory plays a crucial role in shaping our perception of time, influencing how we experience the passing of moments and how we recall events from our past. When we think about time, it's not just about the ticking of a clock, but rather how we remember those moments, the emotions tied to them, and the context in which they occurred. For instance, when we recall a busy day filled with activities, it often seems longer in retrospect, thanks to the numerous memories it generated. Each event creates a snapshot that stretches our perception of time, making it feel as if it was a lengthy experience. Conversely, a day that feels monotonous, where not much happens, can seem to pass by quickly when we look back, due to the lack of distinct memories created during that period. And that's why, when actually drawing closer, we don't see memories created during that period. This interplay between memory and time perception is supported by psychological studies, which suggest that our brain processes memories in a way that can distort our sense of time. For example, during significant life events, such as weddings or graduations, people often report that time seemed to fly by, yet, when they look back on those memories, they can vividly recall many details, providing a rich tapestry of experiences that, in hindsight, makes that time feel elongated. On the other hand, traumatic experiences can have a different effect. Individuals may feel as though time slowed down during the event itself, which is often due to the heightened state of awareness and the intense emotions involved. This can lead to an abundance of memories being formed, which can make the experience seem prolonged. Moreover, our culture and societal norms also impact how we perceive time, as different cultures may have various attitudes towards time, leading to distinct memory frameworks. For instance, in cultures that emphasize living in the moment, people might have a different relationship with their memories and how they relate to their perception of time, compared to cultures that value planning and punctuality, where time may be seen more rigidly, thus affecting how time is processed in memory. Interestingly, aging also plays a role in how we perceive time, as many older adults report that time appears to pass more quickly than it did in their youth. This phenomenon is often attributed to the fewer unique memories formed in later life compared to childhood, where every experience is often new and memorable. As we accumulate more routines and repetitive experiences, the brain may encode fewer new memories, leading to a sensation of time speeding up. In essence, memory acts as a lens through which we view the flow of time. Coloring. In the realm of physics, especially when diving into the intricacies of special relativity, one of the most fascinating concepts to explore is simultaneity, which challenges our everyday understanding of time. In classical physics, we often think of two events occurring at the same time as being simultaneous, but special relativity, introduced by Albert Einstein in 1905, revolutionizes this notion. According to special relativity, simultaneity is not an absolute concept, meaning that whether two events occur at the same time can depend on the observer's frame of reference. This leads us to the idea that two observers moving at different velocities may disagree on whether events happen simultaneously. To illustrate this, imagine two lightning strikes hitting opposite ends of a train that is moving at a significant fraction of the speed of light. An observer standing on the ground, watching the train pass by, would see the lightning strikes as occurring simultaneously, since they are equidistant from the strikes. However, a passenger on the train, moving towards one of the strikes and away from the other, would perceive the strike at the front of the train happening before the one at the back. This discrepancy arises because the speed of light is constant for all observers, regardless of their motion, which leads to different interpretations of the timing of events. This notion is encapsulated in what's known as the relativity of simultaneity, which is a fundamental aspect of Einstein's theory. It is not just a peculiar quirk. It has profound implications for our understanding of time, space, and the universe as a whole. It tells us that time is intertwined with the fabric of space, forming what is referred to as space-time. As a result, the order in which events are experienced can change based on relative motion, thus challenging our intuitive sense of a singular, universal time that ticks away consistently for everyone. Moreover, the relativity of simultaneity has practical applications in technologies such as GPS, where the synchronization of satellites relies on precise calculations that consider the effects of relativity. If we didn't account for the differences in the passage of time for satellites which move at high speeds relative to observers on Earth, our GPS systems would quickly become inaccurate, leading to errors in navigation and timing. This understanding of simultaneity also opens up conversations about the nature of time itself. If two events can be simultaneous for one observer, but not for another, this raises questions about whether time is a universal constant or a more fluid. The relationship between time and free will is a fascinating and complex topic, one that has intrigued philosophers, scientists, and thinkers for centuries. To begin with, free will refers to the ability of individuals to make choices that are not determined by prior causes. While time is often viewed as a linear progression from the past, through the present, and into the future. One implication of time on free will is the notion that our understanding of time can influence how we perceive our ability to make choices. For instance, if one believes that time is predetermined with every moment already laid out, this can lead to the conclusion that free will is merely an illusion, as every decision we make could be seen as preordained, reducing the sense of agency that individuals feel. On the other hand, if time is viewed as a series of possibilities, each moment representing a fork in the road, then the idea of free will becomes more robust. In this framework, every decision we make can be seen as a moment of true choice, where the future is not set in stone and our actions can shape what is to come. This perspective aligns with the concept of open time, where the future is full of potential outcomes, and our choices play a crucial role in determining the direction of our lives. Moreover, the implications of time on free will also extend to how we reflect on our past decisions. The passage of time allows for reflection, learning, and growth, which can influence future choices. When we consider the past, we are often able to evaluate our decisions, learn from mistakes, and adjust our behaviors in the present, thus reinforcing the idea that we possess free will, as we are capable of changing our actions based on our experiences. Additionally, the scientific understanding of time has evolved, particularly with the advent of theories like relativity, which suggest that time is not as absolute as once thought. This has led to discussions about the implications of time on our perception of causality and choice. If time is not a fixed entity but rather something that can be influenced by speed, gravity, or the observer's perspective, then our understanding of free will might also require a re-evaluation. For example, in certain interpretations of quantum mechanics, the act of observing can influence outcomes, which raises intriguing questions about the role of consciousness and free will in shaping reality. Furthermore, the philosophical concept of compatibilism suggests that free will is compatible with determinism, proposing that even in a universe governed by deterministic laws, scientific theories about the beginning of time often delve into the realms of cosmology and physics, offering fascinating insights into how the universe came to be. One of the most widely accepted theories is the Big Bang theory, which posits that approximately 13.8 billion years ago, the universe began as an extremely hot and dense point, often referred to as a singularity. This singularity then expanded rapidly in a process known as cosmic inflation, creating space and time as we understand them today. The incredibly high temperatures and densities of the early universe allowed for the formation of fundamental particles, such as quarks and electrons, which later combined to form protons and neutrons. As the universe continued to expand and cool, these particles came together to form hydrogen and helium, the building blocks of stars and galaxies. Another intriguing concept is the idea of time itself, emerging from the conditions of the early universe. In many interpretations of physics, time, as a dimension, is intertwined with space, forming what is known as space-time. In this view, before the Big Bang, there was no before in the traditional sense, because time, as we experience it, did not exist. This leads to mind-bending questions about the nature of reality, and some scientists even explore the possibility of multiple universes, or a multiverse, where our universe is just one of many that could have emerged from different initial conditions. There's some perception. Additionally, some theories suggest that the universe could have gone through cycles of expansion and contraction, known as the cyclic model. In this scenario, the universe could have experienced a series of big bangs and big crunches, where it expands, slows down, and then collapses back into a singularity, only to explode again in another big bang. This model challenges the idea of a singular beginning, proposing instead that time could be infinitely cyclical. Furthermore, quantum mechanics introduces additional layers of complexity to our understanding of time's beginning. Some physicists theorize that quantum fluctuations in a vacuum could lead to the spontaneous creation of particles and even entire universes, suggesting that the birth of our universe could be rooted in quantum phenomena. This perspective opens up new avenues of thought about the origins of time and space, inviting us to consider the role of uncertainty and probability at the very foundations of existence. In recent years, the concept of time has also been examined through the lens of thermodynamics, particularly the second law, which states that entropy tends to increase over time. This has led to, in the fascinating world of quantum entanglement, time plays a crucial role, influencing how particles interact and remain connected, regardless of the distance separating them. Quantum entanglement occurs when pairs or groups of particles become linked in such a way that the state of one particle instantly affects the state of another, even if they are light years apart. This phenomenon raises profound questions about the nature of reality and the classical understanding of time. In classical physics, time is often viewed as a linear progression where events happen in a sequence, with one event leading to the next. However, in the realm of quantum mechanics, time takes on a more complex and intriguing character. When we consider entangled particles, we see that measuring one particle seems to instantaneously determine the state of its partner, regardless of the distance between them, leading to the idea that information is being shared faster than the speed of light. This challenges our traditional notions of causality and locality, which are deeply rooted in the fabric of time as we understand it. The significance of time in quantum entanglement also touches on the concept of spooky action at a distance, a phrase coined by Einstein, who was famously skeptical about the implications of entanglement. Einstein argued that if entanglement could allow for instantaneous communication, it would require a new understanding of time and space, a challenge that has intrigued physicists for decades. Moreover, the role of time in entangled systems is also tied to the concept of quantum correlation. When two particles become entangled, their properties are correlated in such a way that measuring one immediately impacts the other, regardless of the time it takes for the measurement to occur. This suggests that, in a sense, time may be less of a strict ruler governing events and more of a flexible dimension that allows for connections that transcend typical temporal boundaries. This leads to further exploration of time in quantum mechanics, where the flow of time may not be as straightforward as we perceive it to be. Some researchers are even investigating the implications of time on quantum states and entanglement through the lens of quantum gravity, seeking to unite quantum mechanics with general relativity. This pursuit may reveal deeper truths about how time functions at the most fundamental levels of reality, possibly suggesting that at quantum scales, time could behave differently than we experience in our everyday lives. The implications of all this are profound, as they challenge not only our understanding of time but also the very fabric of reality itself. If time, the concept of time's arrow, which refers to the one-way direction of time from the past through the present and into the future, has significant implications for the philosophy of science, as it raises intriguing questions about causality, the nature of time, and the laws that govern the universe. Philosophers and scientists alike have grappled with the idea that while the laws of physics, particularly those governing fundamental interactions, are often time-symmetric, meaning they do not change when time is reversed, our everyday experience suggests a clear distinction between past and future. This leads to the first point of interest, which is the distinction between the thermodynamic arrow of time, associated with the second law of thermodynamics, and the cosmological arrow, which relates to the expansion of the universe. The second law states that in a closed system, entropy or disorder tends to increase over time, meaning that systems evolve from states of order to states of disorder. And this tendency gives rise to our perception of time flowing in one direction, from past to future. In contrast, the cosmological arrow points toward the unfolding of the universe itself, indicating that as the universe expands, it changes in a way that also suggests a directionality to time. This raises deep philosophical questions about determinism, free will, and the nature of reality. If the laws of physics are time-symmetric, does that mean that the future is predetermined? Or is there room for choice and spontaneity within this framework? Furthermore, the implications of time's arrow extend into the realm of quantum mechanics, where the behavior of particles does not always conform to classical notions of time. Quantum mechanics introduces a level of unpredictability, leading to debates about whether time is a fundamental aspect of the universe or merely an emergent property of more complex interactions. The discussions surrounding time's arrow also touch on the meaning of time itself, as philosophers ponder whether time exists independently of human perception, or if it is a construct of our consciousness. Additionally, the relationship between time and science affects the way we understand scientific theories and models. For example, the way scientific laws are framed often reflects an understanding of time that aligns with human experiences and observations, meaning that our scientific theories, while mathematically robust, may not capture the full essence of time as it exists in the universe. This leads to a philosophical inquiry into whether scientific knowledge is, in some ways, limited by our temporal perspective, and whether our understanding of time can evolve. Time and change are deeply intertwined concepts, often seen as two sides of the same coin, where one cannot exist without the other. When we think about time, we often perceive it as a linear progression, moving from the past, through the present, and into the future. Change, on the other hand, is the process through which things evolve, shift, or transform, and this transformation is what gives time its meaning. Without change, time would simply be a static measurement, lacking the dynamic events that define our existence. For instance, consider how we measure time. Seconds, minutes, hours, days, and years. All of these units signify not just the passage of time, but also the changes that occur within those intervals. The seasons change, people grow older, and technology evolves, all of which are markers of time passing. Each moment that ticks away on the clock brings new experiences, new opportunities, and sometimes new challenges. Philosophers and scientists have long debated the nature of time and change, asking whether time itself is a fundamental aspect of the universe or just a human construct. In physics, particularly in the theory of relativity, time is seen as a dimension much like space, where events occur in a continuum, and the relationship between time and change becomes even more complex. For example, the faster an object moves through space, the slower time passes for it, relative to a stationary observer. This phenomenon highlights how change, particularly in terms of motion, can affect our perception of time. In our daily lives, we experience time and change through various lenses. Personal growth is a profound example, where individuals change over time, learning, adapting, and transforming through experiences, relationships, and challenges. Similarly, in nature, we observe the life cycle of plants and animals, where each stage of life is marked by significant changes. So the metamorphosis of a caterpillar into a butterfly, for instance, illustrates a remarkable transformation that signifies the passage of time and is a beautiful reminder of how change is an inherent part of existence. Culturally, the relationship between time and change is reflected in traditions and rituals that mark transitions. Birthdays, graduations, and weddings are all celebrations that acknowledge the changes that come with the passage of time. These moments allow us to reflect on the changes we've undergone and to celebrate the continuous flow of life, emphasizing the significance of time as it relates to our personal journeys. In essence, time acts as the canvas on which change is painted. Paradoxes of time travel, such as the famous grandfather paradox, significantly influence our understanding of causality, which is the relationship between causes and effects. In the grandfather paradox, a time traveler goes back in time and accidentally prevents their grandfather from meeting their grandmother, leading to the question of how the time traveler could have existed to make the journey in the first place. This scenario raises intriguing questions about the nature of time, existence, and the sequence of events. It challenges our conventional understanding of cause and effect, suggesting that if time travel were possible, the linearity we assume in causality might not hold true, as actions could lead to outcomes that contradict the original timeline. Furthermore, these paradoxes provoke thought about alternate timelines and the multiverse theory, which posits that every possible outcome of a decision creates a new universe. In this view, if a time traveler were to prevent their grandfather from meeting their grandmother, they would not erase their own existence, but rather create a branching timeline where they were never born, while the original timeline remains unchanged. This idea complicates our understanding of causality, as it introduces the concept of multiple realities, where events can diverge based on different choices and actions taken at various points in time. Moreover, the discussion of time travel paradoxes also leads to philosophical inquiries about free will and determinism. If we control in predictable ways. Additionally, scientists and philosophers have explored various models of time travel, including closed time-like curves, which are solutions to Einstein's equations of general relativity that theoretically allow for time loops. These models provide a framework for understanding how causality might work in a universe where time travel is possible. Yet they also highlight the complexities and contradictions that arise from such scenarios. The examination of these theories encourages deeper reflections on the fundamental principles of time and causation, pushing the boundaries of our comprehension of the universe. In conclusion, paradoxes of time travel challenge our traditional notions of causality, compelling us to rethink the relationships between past, present, and future. They open up a wealth of philosophical and scientific discussions, encouraging exploration into the nature of reality, the structure of time, and the implications of human agency in a potentially non-linear universe. Through these inquiries, the concept of eternal return, also known as eternal recurrence, is a fascinating philosophical idea that has intrigued thinkers for centuries. It suggests that the universe and all events within it are eternally recurring, meaning that everything that has happened will happen again, infinitely. This idea raises profound questions about existence, time, and meaning. It can be traced back to ancient philosophies, with early mentions found in Hinduism and Stoicism, but it was Friedrich Nietzsche, a German philosopher from the 19th century, who brought it into modern philosophical discussions. Nietzsche used this concept as a thought experiment to explore how one might live their life if they knew that every action, every joy, and every pain would recur indefinitely. The significance of the eternal return lies in its challenge to our understanding of time and existence. It forces individuals to consider the weight of their choices, highlighting the importance of living authentically and fully. If one were to embrace the notion that their life would repeat itself, could inspire them to live in a way that feels meaningful and fulfilling instead of simply going through the motions. This idea also provokes existential questions, prompting individuals to confront their beliefs about fate, free will, and the nature of reality. Moreover, the eternal return can be seen as a way to cope with the inherent suffering of life. You can take out the nature, everything to do with it. By contemplating the cyclical nature of existence, one might find solace in the idea that all experiences, both good and bad, are part of a larger repeating pattern. This perspective can foster resilience, encouraging individuals to accept their circumstances and embrace life in all its complexity. In literature and art, the concept of eternal return has been explored in various forms, often serving as a backdrop for narratives that delve into the human experience. It invites creative expressions that grapple with themes of time, memory, and the nature of existence. By examining the eternal return, artists and writers have the opportunity to reflect on the significance of their work, considering how their creations may resonate across time and space. In summary, the significance of the eternal return in philosophy lies in its ability to provoke deep reflection on how we live our lives, how we perceive time, and how we find meaning in the experiences we encounter. It encourages a re-evaluation of our priorities and values, urging us to consider the impact of our choices in the grand tapestry of existence, where every moment is precious and potentially eternal. Different scientific theories approach the nature of time in fascinating and varied ways, reflecting deep philosophical questions as well as empirical observations. From this calm, still, limitless pen, in classical physics, particularly in the framework established by Isaac Newton, time is viewed as an absolute entity, flowing uniformly and independently of the events occurring in the universe. This idea suggests that time is a constant backdrop against which all physical events unfold, allowing for the measurement of durations and intervals that remain the same regardless of the observer's state of motion. In contrast, Albert Einstein's theory of relativity revolutionized our understanding of time, merging it with space into a four-dimensional continuum known as spacetime. According to his special theory of relativity, time is not an absolute entity. Instead, it is relative and can vary for different observers depending on their velocity and the strength of gravitational fields. This means that time can appear to pass at different rates for people who are moving at different speeds or are located in different gravitational environments, leading to the intriguing concept of time dilation, where, for instance, astronauts traveling at high speeds in space age more slowly than people on Earth. Moreover, in the realm of quantum mechanics, time becomes even more complex. Some interpretations suggest that time may not be a fundamental aspect of reality at all, but rather an emergent property arising from deeper, more fundamental processes. In this view, the flow of time could be seen as a construct of human perception, rather than a fundamental feature of the universe. This idea has been explored in theories like loop quantum gravity, which attempts to reconcile general relativity with quantum mechanics, proposing that space and time are made up of discrete units at the smallest scales. Additionally, the philosophical implications of time have led to various debates. For example, the presentist view posits that only the present moment is real, while the past and future do not exist in any tangible sense. It portends that, in contrast, eternalism suggests that all points in time, past, present, and future, are equally real, with time viewed as a dimension similar to space. This leads to intriguing discussions about free will, causality, and the nature of existence itself. Moreover, some physicists explore the concept of time as a loop, where the universe could be cyclic, with time repeating itself in a grand cosmic cycle. This idea emerges in certain cosmological models that suggest the universe could undergo infinite expansions and contractions, giving rise to a new interpretation of time that is non-linear and cyclic, rather than linear and one-directional. In the field, the theory of relativity, developed by Albert Einstein in the early 20th century, has dramatically changed our understanding of time and space, particularly when it comes to the concept of simultaneity. which refers to the idea that two events occur at the same time. In classical physics, simultaneity is absolute. If two events happen at the same moment for one observer, they happen at the same moment for all observers, regardless of their relative motion. However, Einstein's special relativity introduced a new perspective, showing that simultaneity is not absolute but relative, depending on the observer's state of motion. This means that two observers, moving at different velocities, may disagree on whether two events occurred simultaneously. For example, consider two lightning strikes that hit two different locations. For an observer standing midway between the two strikes, they will see both strikes occurring at the same time. However, an observer moving towards one strike and away from the other will perceive one event occurring before the other, leading to a fascinating conclusion. Simultaneity is relative to the observer's frame of reference. This is not just a quirky feature of physics. It has real implications in various fields, including astrophysics and GPS technology. In the context of GPS, satellites are moving at high speeds relative to the Earth's surface, and their onboard clocks tick slightly faster than those on the ground due to the effects of special relativity. If this discrepancy were not accounted for, GPS systems would quickly become inaccurate, leading to errors in navigation. Moreover, the impact of relativity extends to the concept of time dilation, which indicates that time passes at different rates depending on the relative speeds of observers. This further complicates our understanding of time and simultaneity, as events that are simultaneous in one frame may not be in another, creating a rich tapestry of interactions that challenge our everyday intuitions about time. Consequently, relativity has not just reshaped theoretical physics, it has also influenced how we understand the universe, our place within it, and the nature of reality itself, prompting deeper inquiries into the very fabric of time and space. This shift in perspective has led to profound philosophical questions about the nature of time, existence, and our perception, pushing the boundaries of science and inviting us to rethink what we consider to be fundamental truths about the world around us. Theories of time and existentialism are deeply intertwined, as each explores the nature of existence, consciousness, and the human experience in relation to the passage of time. Philosophers have long debated the nature of time, whether it is linear, cyclical, or even an illusion. In existentialism, which focuses on individual freedom, choice, and the search for meaning, time plays a crucial role in shaping our understanding of existence. Existentialists like Jean-Paul Sartre and Martin Heidegger emphasize that our awareness of time influences how we live our lives, as it underlines the urgency of our choices and the inevitability of our mortality. Sartre, for instance, posited that humans are condemned to be free, meaning that we must confront the weight of our decisions in a world where time is always moving forward, creating a sense of anxiety but also a potential for authentic existence. Heidegger, on the other hand, introduced the concept of being toward death, which suggests that our awareness of our own mortality shapes our understanding of time and existence. He argued that acknowledging our finite nature compels us to live more authentically, as it forces us to confront the reality of our choices and the limited time we have. This idea can be seen as a call to embrace the present moment, to live fully in the now, rather than getting lost in regrets about the past or anxieties about the future. Therefore, turn to your inner BF. Look around. In the existential framework, time is not merely a measurement, but a fundamental aspect of human experience that shapes our identities, relationships, and the meanings we ascribe to life. Additionally, the perception of time can vary significantly between cultures, influencing existential thought. Some cultures may view time as cyclical, where events repeat in a never-ending loop, while others see it as linear, with a clear beginning and end. These differing views can impact how individuals relate to their existence, with cyclical perspectives fostering a sense of continuity and connection, while linear views may emphasize progress and individual achievement. Existentialist thinkers often grapple with these variations, reflecting on how they affect personal identity and the quest for meaning in life. Moreover, the interplay between time and existentialism raises questions about how the past, present, and future shape our understanding of self. The existential notion of existence precedes essence highlights the idea that we create our identities through our choices. Over time, our past experiences influence who we are today, while our aspirations and goals for the future guide our current. In the realm of cosmology, time holds a profound significance, as it serves as a fundamental dimension alongside space, shaping our understanding of the universe's structure and evolution. The concept of time in cosmology is not merely about the ticking of a clock, but rather it is intricately linked to the very fabric of space-time, a term coined by Albert Einstein in his theory of general relativity. According to this theory, time is affected by gravity and the curvature of space-time, meaning that time can flow differently depending on one's position in a gravitational field. This phenomenon, known as time dilation, has been confirmed through experiments with atomic clocks flown in aeroplanes, which show that time indeed passes more slowly at higher gravitational potentials. In cosmology, time also plays a critical role in our understanding of the universe's history and its eventual fate. The Big Bang Theory, which describes the origin of the universe approximately 13.8 billion years ago, relies heavily on the concept of time, as it marks the beginning of both space and time as we know them. This event was not just a cosmic explosion, but rather an expansion of space itself, leading to the formation of galaxies, stars, and planets over billions of years. As cosmologists study the cosmic microwave background radiation, the afterglow of the Big Bang, they can infer the age of the universe, providing a timeline of its development from a hot, dense state to the vast expanding cosmos we observe today. Moreover, the significance of time in cosmology extends to the study of cosmic events, such as the life cycles of stars, which can span millions to billions of years. Understanding these processes requires a timeline that allows astronomers to explore how stars are born, live, and die, often culminating in spectacular phenomena like supernovae, which can outshine entire galaxies for a brief period. The time it takes for light from these events to reach us also adds another layer of complexity, as we often observe these cosmic occurrences. In addition to the physical aspects of time, there are philosophical implications as well. The nature of time raises questions about determinism and the flow of events, leading to debates among physicists and philosophers alike. Some argue that time is an illusion, a construct of human perception, while others maintain that it is a real and measurable dimension that plays a crucial role in the laws of physics. The exploration of time also leads, the concept of time plays a crucial role in shaping human psychology, influencing our behaviors, emotions, and overall mental well-being in profound ways. One interesting aspect is how our perception of time can alter our experience of the present moment. For instance, when people are engaged in enjoyable activities, time seems to fly by, while during moments of boredom or discomfort, it can feel like time is dragging on endlessly. This phenomenon is often referred to as time distortion, and it can have a significant impact on how we process our experiences, affecting our mood and overall satisfaction with life. Moreover, our understanding of time can also affect our decision-making processes, and the question, do we have time? Now, a little discussion is of interest to medics, who pose a broader picture that highlights the sum total of the default reaction to life. Research shows that individuals with a more future-oriented mindset who focus on long-term goals and outcomes tend to make healthier choices, such as saving money, exercising regularly, and maintaining relationships. In contrast, Those who are more present-oriented may prioritize immediate gratification, which can lead to impulsive decisions that might not benefit them in the long run. Or, this interplay between time perception and decision-making highlights the importance of our relationship with time in shaping our behavior. Additionally, the way we conceptualize time, whether we see it as linear or cyclical, can influence our cultural practices and social interactions. For example, in many Western cultures, time is viewed as a linear progression from past to future, which encourages punctuality and a focus on planning. In contrast, some indigenous cultures view time as cyclical, where past, present, and future are interconnected, leading to a different approach to life and relationships. This cultural perspective can affect how individuals experience stress, prioritize tasks, and engage with their communities. Time also plays a significant role in our memories and how we relate to our past. The way we remember events often changes over time, as our current emotional state and life experiences can shape our recollections. Nostalgia, for instance, can be a powerful psychological tool, allowing individuals to revisit happy memories, but it can also lead to feelings of loss if one longs for the past. This relationship between time and memory can impact mental health, as individuals may struggle with regret or anxiety related to their past choices, while also finding solace in positive memories. Furthermore, the fast-paced nature of modern life, characterized by constant connectivity and the pressure to be productive, can lead to a sense of time scarcity. Many people report feeling overwhelmed by the demands on their time, which can result in stress and anxiety. This sense of urgency can impair our ability to be present, and the impact of technology on our perception of time is profound and multifaceted, as it has significantly altered how we experience and manage our daily lives. With the advent of smartphones, social media, and instant communication tools, our relationship with time has transformed dramatically. For instance, the ability to connect with anyone around the globe in real time has made us more aware of different time zones and cultures, leading to a sense of urgency, as we now expect immediate responses and instant gratification. This shift has resulted in a faster pace of life, where waiting for anything, whether it be a reply to a message or a download to complete, seems increasingly intolerable. Moreover, technology has also changed how we allocate our time. With countless apps and tools designed to help us be more productive, many people find themselves caught in a cycle of multitasking, believing that they can accomplish more by juggling various tasks at once. However, studies show that multitasking can actually decrease overall efficiency and increase stress levels, as our brains struggle to focus on multiple things at once. The constant notifications from our devices can fragment our attention, leading to a feeling that time is slipping away as we are pulled in various directions, distracted from the task at hand. Additionally, the rise of streaming services and on-demand content has created a culture of binge-watching, where the lines between leisure time and work time blur. People can easily lose track of hours as they become engrossed in an entire season of a show, leading to a distorted perception of time spent. This phenomenon is especially pronounced among younger generations, who often prioritize screen time over face-to-face interactions, further affecting their sense of time and how they perceive its passage. On the other hand, technology also offers tools that can enhance our time management skills. Digital calendars, reminder apps, and productivity trackers can help individuals organize their schedules more effectively, allowing them to allocate their time to various activities more thoughtfully. This can lead to a better understanding of how time is spent and potentially a more satisfying experience of time, as people are able to focus on what matters most to them. Furthermore, the concept of time has also been affected by global connectivity. With the internet, people are no longer bound by traditional schedules. Work can be done asynchronously, and meetings can occur at any time, creating a sense of timelessness. This has led to a phenomenon known as time compression, where the boundaries between work and personal life become increasingly indistinct, often resulting in longer. The concept of time plays a crucial role in shaping artistic expression, influencing not just the content of art, but also the techniques, mediums, and even the emotional responses evoked in audiences. Mening punista. Heretanza artists often reflect on their own experiences of time, whether it's the fleeting nature of a moment, the historical context in which they live, or the timeless themes that resonate across generations. For example, consider how Impressionist painters like Claude Monet captured the effects of light at different times of day, using quick brushstrokes to convey the transitory beauty of a sunrise or sunset. But this approach emphasizes the momentary aspects of reality, inviting viewers to appreciate the beauty of the now, while also reminding them that such moments are ephemeral. On the other hand, some artists delve into the concept of time through the exploration of history and memory. Artists like Salvador Dali, with his famous melting clocks in the persistence of memory, challenge our perception of time by suggesting that it is a fluid and subjective experience rather than a rigid linear progression. This can lead viewers to ponder their own relationship with time, reflecting on how memories fade or how certain moments seem to stretch or contract in our minds. Moreover, performance art relies heavily on the concept of time, as it often unfolds in real time, creating a unique experience for both the artist and the audience. When an artist performs, the duration of the piece, the timing of movements, and even the pauses all contribute to the overall impact. This immediacy can heighten emotional responses, making the audience acutely aware of the passing moments, as they witness the unfolding of a story that is never repeated in exactly the same way. In literature, time is a central theme that influences narrative structure and character development. Writers like Virginia Woolf in Mrs. Dalloway experiment with time through stream of consciousness techniques, allowing readers to experience the characters' thoughts and memories in a non-linear fashion. This method invites readers to feel the weight of past experiences as they intermingle with present events, creating a rich tapestry of human experience that reflects the complexity of time in our lives. Furthermore, the influence of time on artistic expression is also evident in the evolution of styles and movements. Art history shows us how periods, such as the Baroque or the Romantic era, were heavily influenced by the societal understanding of time, progress, and change. Artists responded to the technological advancements and philosophical shifts of their time, creating works that embody the spirit, the concept of timelessness, which suggests the existence of a reality that transcends the flow of time, opens up a plethora of philosophical implications that have intrigued thinkers for centuries. At its core, timelessness challenges our conventional understanding of existence, which is often anchored in the past, present, and future. If we consider a state of timelessness, we must grapple with questions about causality, change, and the nature of reality itself. For instance, if something exists outside of time, does that mean it is unchanging? Or can it still engage with the temporal world in meaningful ways? This brings us to the philosophical debates around the nature of change. Some philosophers argue that change is an illusion, a mere perception of our consciousness, while others maintain that change is fundamental to existence. Furthermore, the idea of timelessness raises significant questions about free will. If there is a timeless realm where all moments exist simultaneously, it challenges the notion of linear progression and the idea that our choices are entirely free. Do our decisions have meaning if they are already predetermined in a timeless reality? This discussion touches on determinism versus free will, a long-standing debate in philosophy. The implications extend to ethics as well, as moral responsibility may hinge on our understanding of time and choice. If every action has already occurred in a timeless context, then the moral weight of our decisions might be perceived differently. Moreover, The concept of timelessness invites contemplation about the nature of the divine. Many religious and spiritual traditions describe God or the ultimate reality as timeless. This leads to rich discussions about the relationship between the divine and human experience. If God exists outside of time, how does that influence our understanding of prayer, miracles, and divine intervention? Does it suggest that time itself is a creation, a framework within which we operate, while the divine operates beyond it? In addition, timelessness raises intriguing questions about memory and identity. If our identities are shaped by our experiences over time, what happens in a timeless context where all experiences are equally present? This leads to explorations of how we conceive the self and whether our identities are fluid constructs or fixed entities. The notion of timelessness can also influence how we perceive the universe itself. If time is not a fundamental aspect of the cosmos, does that mean that the universe is more interconnected than we perceive, where past, present, and future are merely different perspectives on the same reality? Lastly, timelessness can have profound implications for the meaning of life. Theories of time, which explore how we understand and perceive time, intersect with the nature of reality in fascinating and complex ways. Traditionally, time has been viewed as a linear progression, moving from the past through the present and into the future, a perspective that aligns closely with our everyday experiences. However, in the realm of physics, particularly in the theories of relativity proposed by Albert Einstein, time is not as straightforward as it seems. In this framework, time is intertwined with space, forming a four-dimensional fabric known as space-time. This means that time can be affected by speed and gravity, leading to phenomena like time dilation, where time appears to pass more slowly for an object moving at high speeds compared to one at rest. From this perspective, the nature of reality is not merely a series of moments strung together, but a more intricate tapestry where time and space bend and warp, challenging our conventional understanding of cause and effect. Moreover, theories from quantum mechanics introduce even deeper questions about time and reality. In the quantum realm, particles can exist in multiple states simultaneously, and their behavior can seem to defy the linear progression of time. The concept of quantum entanglement suggests that particles can be connected in ways that transcend spatial and temporal boundaries, leading to intriguing implications for how we understand reality itself. Some interpretations of quantum mechanics propose that time may not be as fundamental as we think. Instead, it could emerge from more basic processes. This challenges our perception of reality, as it implies that what we experience as a continuous flow of time may be an emergent phenomenon rather than an intrinsic feature of the universe. The intersection of time and reality raises questions about determinism and free will. If time is predetermined and all events are fixed along a timeline, what does this mean for our ability to make choices? Conversely, if time is fluid and subjective, it suggests that our experiences and decisions may play a more active role in shaping reality. The debate between presentism, which posits that only the present moment is real, and eternalism, which argues that past, present, and future events equally exist, further complicates our understanding of time. Each theory offers a different lens through which to view reality, influencing everything from our daily lives to the fundamental nature of the universe. In the center is a value present to science. In addition to scientific and philosophical perspectives, cultural narratives around time also contribute to our understanding of reality. Different cultures have various ways of conceptualizing time, from cyclical views. In the ever-evolving field of physics, the study of time and reality is taking on exciting new dimensions, as researchers are delving deeper into the fabric of our universe, exploring concepts that challenge our understanding of existence itself. One of the prominent directions is the investigation of time within the framework of quantum mechanics, where scientists are probing the idea that time may not be as linear as we perceive it. Quantum entanglement, for instance, raises questions about the nature of time, suggesting that particles can be interconnected across vast distances, seemingly defying the conventional flow of time we experience in our everyday lives. This has led to theories that